A professor wants to see how the number of absences for the students in their class affected the student's final grade. The data from a sample of their students are shown. We want to find the correlation coefficient and interpret the correlation coefficient in terms of the context of the question. We want to give the equation of the linear regression, and then we're going to interpret the slope and the y-intercept. We're going to use the equation to predict the grade of the students with 8 absences, and finally we're going to find the residual for students with 3 absences. And then we're going to say whether the equation overestimating or underestimating their grade. So to find the correlation coefficient, I took the data to an Excel sheet, and we're going to use the function correl on Excel. Correl is asking for array 1, array 2, so it doesn't matter which set of data you choose first. I'm going to choose absences and then comma, final grade, and then click enter. So that is going to be the correlation coefficient. This correlation coefficient means that there is a strong correlation, strong negative correlation between the absences and the final grade. In other words, the more absences, the lower the final grade is going to be. So now we're going to find the equation of the least square regression line, or the regression line equation. So we're going to find the slope. The slope, we're going to use the function slope to find it. The slope asks for known y's, then known x's. So the known y's are the dependent variable. In this case, the final grade depends on the absence. This is very important to distinguish the difference between the dependent variable and the independent variable. If it helps, you can basically label them. You can go ahead and label that. You can say this is y and this is x. Y is basically the dependent variable. X is the independent variable. The independent variable affects the dependent variable. And then we're going to say comma and then x's, known x's. We're going to select the absences in this case and click enter. So that is going to be the slope. The y-intercept is computed using the intercept function. So let me just fix that. So intercept, double click again. Similar to the slope, it's asking for the grade first, which is the dependent variable or known y's, and then comma, you're going to say the absences or the independent variable. So now we can create our equation. Remember that the equation is of the form y equals to, or y hat, sometimes you see it like that, mx plus b. M is the slope and b is the intercept, so we can write it as negative 2.77x plus 98.12. You can round to 2 decimals. I think that's reasonable. So that is going to be the equation for the least square regression line, or for the regression line. Now, the interpretation of the slope, we know that the slope is negative in this case. We interpret it usually by seeing what happens as x increases 1 unit at a time. 1 unit of x increase means the students as absent 1 day. So for each 1 day of absence, the final grade is expected to be reduced or decrease an average of 2.77, which is basically the slope. And then the interpretation of the y-intercept, again, in the same context, we're going to look at the equation, and we're going to interpret the equation when x is equal to 0. When x is equal to 0, that means the student doesn't have any absences. So when the student doesn't have any absences, we expect the final grade of that student to be the y-intercept, which is 98.12 points or percent. Then we're going to use the equation in order to predict the grade of the students with 8 absences. To do that, I'm going to go to Excel, and instead of x, I'm going to take x out and plug 8. So y equals negative 2.77 times 8 absences plus 98.12. So I'm going to do the precise answer here. So I'm going to say the slope times 8 plus the y-intercept gives me the absences, the grade of the students with 8 absences. So the answer is 75.94. Finally, we're going to find the residual for the students with 3 absences. So to find the residual first, let's identify the observed value for 3 absences. So the observed value for 3 absences is 91. So for 3 absences, the observed grade is 91. Now we need to find the predicted grade. The predicted grade comes from the equation. We're going to take the same equation and we're going to plug 3 instead of x. I'm going to compute the value here. So I'm going to say 3 absences here is equal to the slope times 3 plus the y-intercept. And now the residual is the observed value minus the predicted value. So equals the observed value, 91, minus the predicted value, which is we computed here. So I'm just going to click on it. So it's 1.19. That is the residual. So what you're going to write here, you're going to say residual is equal to 91 minus 89.80, which is going to give me 1.19. Notice here how the observed value is bigger than the predicted value, which means the equation underestimates their grade.